All right. So, good morning, and yeah, welcome back. We are now in week number 4 of the Geo-Python course, and so we've covered basics of Python. We've covered things like how to do and handle Python lists and index values. And last week we were talking about for loops and conditional statements, and we're going to continue from there today, learning about functions. And so we'll get to that. But of course, yeah, we'll start with the feedback you've given here about last week. And there's a few questions here. The first one about PEP. I think it's Python Enhancement Proposal or something like that. I just looked it up because I can never remember what it is. Yeah, it's Python Enhancement Proposals. There's a whole bunch of them that cover various quite specific things about Python, but PEP 8 is perhaps the most useful for kind of teaching yourself good skills as new programmers, because it talks more or less about how to format your code to make it easy to read. And by having some kind of consistent styling, it means that everyone's code is a bit easier to read. If there were no guidelines about how to format things, you might imagine it gets quite messy, and some other programming languages are very flexible about how you format your loops and things like that, which can make it really, really hard to read your code and quite variable between people because there is no consistency. So it's actually kind of a nice thing that Python has this set of guidelines to help make your code easier to read, because I think honestly it does make a big difference. Regarding the sort of challenges in the course and the lab sessions, yeah, of course, as we go on, we get a little bit more advanced, and I think you'll find that in weeks 5 and 6 in the course, when we start dealing with this data science library called pandas, that things usually see a little bit more of a step in that week. It's not necessarily an insurmountable step. It's just that that seems to be the week where students typically have a bit more of a challenge to understand how things are progressing. But we make a big leap in the sense that we start dealing with data files. We start actually doing things that really allow you to do more powerful things with Python than simply write loops and process things that you've typed in. So anyway, yeah, it's maybe getting a little bit more challenging. I think the message from the course assistants is that the exercise sessions have been somewhat low attendance, I would say. We met with them last week just to kind of see how things were going, and they were saying that they were encouraging you folks to attend the exercise sessions. So if you're having trouble, please do drop in on Thursday and Friday to those sessions. The course assistants also wanted us to remind you that for those course kind of extra sessions, you can come anytime in the 4-hour window. You don't have to sort of show up at the beginning or whatever. Don't have to worry about being late. Anytime you're free during that 4-hour period, you can drop in. And if you're having questions or unsure about something, I would guess that oftentimes a few minutes talking to one of the course assistants would help clarify things, and then it may actually help you to move forward rather quickly compared to sort of staring at the screen trying to figure it out yourself. It's worthwhile to do that for some period of time, but it's also good sometimes to ask someone to explain something to you, because maybe they'll use a different way of explaining it than what we do on the course page that makes more sense to you. So yeah, I mean, my impression is that normally the course assistants will try to give you kind of one-on-one help in these exercise sessions. So it's a very good place to go to get some help. Took a while to understand how to use index values as part of the for loop. Yeah, that's quite typical, but I think it's a good thing to go through trying to understand how to do that, because it's also the case that you will often use an index value to loop over things like multiple lists. So that's a handy thing to know and learn to do. The question here about the main part in problem number 3 and kind of not being sure if we knew how to do that. Yeah, I mean, in essence, I think we did provide enough kind of background on that, but typically with the exercises, part of the idea is to not just take what we learned in class, but to kind of build a little bit on what we learned in class. So we try to demonstrate things during the class time with I would say, relatively simple examples. And then for the exercises, often you're asked to build on that a little bit. So let me see if I can maybe just show what this exercise 3 question was, just in case you're unclear about that exercise. I think we can see it here in GitHub. I won't open it up in CSC notebooks because it's not cloned here. But essentially, this was the question where we were trying to classify these different site locations, so these different FMI weather stations into the sort of northwest, northeast, southwest, and southeast zones based on some arbitrary central location in Finland. The idea here is that you were given the stations, the latitudes and longitudes, and kind of similar to what we did with looping over the for loop using an index value, you could basically go through and loop over all of the values here, and you would then have a location in the stations list that you could use that index, like let's say index 0 to refer to the first location in stations, as well as the first latitude and the first longitude, those 3 things all in separate lists, but all being related to one of the stations there. And the idea was that you have this north-south cutoff and an east-west cutoff, so that as you're looping through the values, you could basically check and say, okay, for the latitude, for example, when I'm at the first location, index 0, is my latitude greater than or less than 64.5? And that would tell you, are you in the north or are you in the south? And similarly for the east-west, you could then do the same kind of comparison that if you check to see your longitude, you could say, okay, is it less than or equal to 26.3? And if that was the case, then that would tell you you were in the west. And if it was greater than 26.3, you were in the east. And using that combination, then you could basically identify which one of the 4 zones your station was in. So it was perhaps a little bit more complicated than the example we gave during class, but the basic idea behind it was to use a for loop with the index value that you're looping through all of the stations here and then checking their latitude and longitude to figure out which location the station was in. So if you still have questions about that, you're of course welcome to ask us or ask the course assistants, or you can always post something in I guess in Discord as well. Need to get my brain working this morning. So, yeah, okay, good to hear that the exercise session and assistance helped with the index values. Weather station exercise was a pain. Yeah, I mean, I think that's sometimes these lessons are a bit painful. Nothing totally surprising there. And yeah, understood the loops fairly well, but not enough to complete the extra assignment. So. Yeah, we could show, I think, quickly how to do the extra assignment, just in case you're curious. It's, I don't know, maybe I can demonstrate, and Kamyar, if you have a different approach to it, you could also demonstrate the same thing. Maybe just to first take a look at what the exercise was. This problem number 4, the idea was we wanted to produce this flag pattern. And the flag pattern basically comprises 7 stars, and then I think there's, I don't know, 13 dashes or something like that after this. So anyway, you had the idea that you had this pattern that you wanted to produce. So let's see if I can figure out how to do this. I'll just copy the pattern, and I'm going to go here and just make a new notebook just to show that. And just for reference, I'm going to put here the flag pattern. And now the fun part. So I'm just going to then paste in the flag pattern like that so we can see it. And basically the idea here was that we suggested to use nested for loops for this. So the point here is that when you have this pattern that is different in the sort of horizontal and vertical directions, that you probably, I mean, there's other ways to solve this, but you probably want to use two for loops. And so we can start with one that will loop over the number of, let's do it over the number of rows. So we could say for I in range 5, since we have 5 rows. And we do it like that. And then for j in range, so remember that I and j are often used as these kind of iterator variables. They're easy to type in. For I in range, and then we said we had, I think it was 7 stars, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 characters in the length of that line. This is going to basically allow us to go to each one of these places. So we'll start in the first row, and we're just going to go across. Each time we iterate within this inner loop, we're going to go across from the first character to the end of the line. And we want to figure out, based on what row and what column, or what kind of character position we're in, whether we want to add a star or one of these dashes to the flag pattern. So let's start out first before this, and we'll make our flag. I don't remember even what it was supposed to be equal to, but let's just say it's empty to begin with. And our idea here would be that in the first little corner, we should be putting in stars, and everywhere else we're going to put in a dash. So we can basically say here, within our loop, that if our row is less than the third row, and our character in that row is less than the 7th character, we're going to put in a star. So we could say, for instance, here, if I is less than 3, which means it would be 0, 1, or 2, so that's the first 3 rows. And let's do this as a combined thing, because why not? So if I is less than 3 and j is less than, and in this case, we want less than the 7th character because there's 7 stars going across. So j is less than 7, and that's going to be 0, 1, 2, 3, 4, 5, 6 in terms of the index values, so less than 7 is okay here. We're going to take our flag pattern and say our flag equals flag plus, and then the star character. So let's add a couple comments here just for the sake of clarity. So loop over the rows and loop over the columns. And then here we could say add a star if in rows 1 to 3 and columns 1 to 7. So essentially we're just identifying with this test, are we in the top left corner of this little pattern we're trying to generate? If both of these conditions are met, we'll put a star. If not, what we want to do is say flag equals flag plus, and we'll put a dash there instead. So remember that because the loop is going to go to the first row and then go all the way across it, and then the second row and go all the way across it, essentially all we're doing is we're just checking each time when we get to a given position, are we in the corner or not, and then we put in the corresponding character. There's one thing we need to do to add to this to make it work properly, and that's the fact that when we get to the end of one of the lines, we need to add in a special character here to indicate that we are at the end of the line. Otherwise, it's just going to make one long, like stretched out flag that is however many characters long, but it won't have different rows. It will just be one continuous string. So here, in our inner loop, we're basically deciding what character to add to the flag, but here's the loop on the outside where we are just going over the rows. When we finish going across each position in a given row, we want our flag to have this special character added. And so we say flag equals flag plus, and this is going to be one we haven't seen yet. How do I do this one? Is it this? There we go. I got to put this in quotation marks. This \n character is a special character in a Python character string that indicates the end of a line. It's called a new line character. When Python encounters that, it just wraps the text to the start of the next line. So each time we get to the end of one of the rows, at the last column, we add this new line character, and then we continue on from there. So the idea is that within a given row, we're going to do all this stuff here to check and see which character we should add, but at the end of the row, we're going to then add this new line character to fill in the need that at the end of this, we should basically start at the next row. I think like that, everything should be more or less okay with the code logic. And then we can simply print our flag at the end of this. Let's see if it works. Okay, I think that looks like the right pattern. So obviously we didn't go through these nested loops in much detail during class, and so don't worry too much about that. If this is a little bit more advanced, this is why we make it an optional exercise. But the idea is that it's not uncommon when you have sort of table-like data to have this thing where you have two loops and you just go through like value by value, checking the first row, all the values, second row, all the values, and so on. Of course, with this simple example, you could just think about like, well, maybe I could just use one loop and say if I'm in the first three rows, then print, this, like, just this piece here. Let's see if I can. So like if you're in the first three rows, you could say, okay, just print this character string of like 7 stars and then whatever number of dashes after that. And then if not, then just print only dashes. So, I mean, there are perhaps faster ways to do this, but this was the example from the optional problem number 4. Are there any questions about that? Did anyone manage to get this working themselves? Okay, at least one. So, yeah, anyway, there are optional problems in some of the different exercises, so if you're up for it, if you have time that week, it can be fun to play with them, and maybe you'll learn something that way too. But yeah, let's jump back here. So I think that covers all the kind of introductory questions. I just wanted to add a couple things from the course assistance just as some notes for you. So we, like I mentioned, talked to them last week, and they gave the following feedback to us. One thing is that for the exercises, course assistants would recommend that you read over the exercise in detail first before you get started doing it. It seemed like there were perhaps a number of cases where some of the problems that came up were things that could have perhaps been resolved just by reading over the exercise a bit more carefully. So please do just read it over before you get started writing your code, and it might save you some time and some stress as well. They also noted that you should make sure that you copy your personal version of the exercise to your CSC notebooks. So like when you click on this GitHub Classroom link each week to make the exercise, it makes a personal copy for you, and you only have permissions to make changes to your personal copy. So if you try, for instance, using the kind of template of the exercise, which is also there's a link to that on the course webpage, you won't be able to make any changes to the template, and you'll get error messages that say you don't have permission to push changes to that repository. So yeah, please make sure when you copy the exercise to CSC notebooks that you're copying your private one which should be the one that like has the exercise name and then your GitHub username at the end of it. Otherwise, yeah, they just encourage you to join the exercise session. It's a good place to get help with Git. So if you're still confused about how Git's working, that's a really nice place to get some one-on-one help with figuring out how all of that works. And they also suggested that you start, just have a look at the exercise sometime earlier in the week before coming to the exercise sessions, just because maybe you can make the most of your time there if you've had a look at the exercise first. Any questions or anything about how things are going so far? Okay, so if not, I think I will turn things over now to Kambyar for the first part of today's lesson, and yeah, we can get started. If you haven't opened up the CSC notebooks yet, please do that now.
Okay, good morning everyone. So as usual, just go to Notebook, open a new session. I have already opened the session and cloned I pulled the latest changes, so I have the lessons already open here. If you haven't done it already, do it now. Okay, so maybe we can slowly start so we don't run out of time while a few are still trying to get the latest lesson. So yeah, course overview. So today we are going to talk about, as David already mentioned, we are going to start talking about functions. Functions are they're one of the most important concepts in programming, and it's not limited only to Python. So we are going to talk about functions first, and then we will talk about modules or libraries, as they are called in some of the programming languages, the related concepts. And in between, we will have a short lesson on use of large language models and AI, particularly ChatGPT. We will just have a demonstration on how we can use it for programming or for producing part of our code. So the idea is that we will have some experience with that, and you will see the pros and cons, what is good and bad about them. So that's the overview of this lesson. So by the end of today's lecture, you will be able to explain how functions are used, and you will know the benefits for programming. You will be able to describe the pros and cons of using AI models for producing part of the code in your work. You will be able to create your own functions and calculate the output value based on some input that you provide. And you will be able to save the functions you create to a script file which you can use later. Okay, let's get started. Functions. So hopefully most of you have managed to pull the latest changes, and now you should have the notebook files here. So we start with the function. Okay, so what is a function? Well, function is a block of organized, reusable code that can make programs more effective. So during this course, during the past 3 lectures, we have already told you a few times that it's a good programming practice to avoid repetition of code. So if you have some task, you have something that happens several times during your program, it's not advisable to repeat the same piece of code over and over. That's not a good practice, and it's of course so much work for you if you're writing a bigger program. So we have seen already ways of, at least one way of avoiding repetition in code. For example, if you're iterating through some process, if you have a big data and you're going through rows, for example, the flag example that David just showed you. In this kind of case, we use for loops. It provides you a way of looping through things so you don't repeat things. Another way, this is a totally different thing, but this is also with the aim of avoiding the repetition of code. It's creating a function. So imagine you have some task. It may not be iterative like a for loop, but it's a task that you might need to perform every now and then in your program. So one way of doing it is you just write the code over and over, which is not a good practice. The other way is that you just define the function somewhere separately. So it's a bunch of code, it's a bunch of organized code that performs a certain kind of task. So whenever during your program you have the need to run that task, you just call the function without repeating the code. So that's the idea behind functions. And although we haven't talked about it explicitly so far, you have been using functions already. For example, with the print function, when we are printing something to the screen, it's a built-in Python function. So it provides some instructions to computer, so it knows what to do to show the message on the computer. So you don't have to do it every time. You just say, I want to print something, you provide the text or whatever you want to print, and it will do the job for you. So that's an example of a function that we have been using already so far. So let's look at the anatomy of functions. So functions in principle are not so different than the functions we have learned about when we're studying mathematics. So you have a function, it performs a task, it calculates, for example, something for you, and then you provide some inputs and it gives you some output. So the logic is quite similar. So let's look at how that works. How do we define it? So one of the first things when you want to define a function, when you want to use a function, the first step is to define the function in your program. And for doing that, you write definition. So this is a keyword that, again, we have seen many keywords during our work with Python, the words that are reserved for doing certain things in Python. So for example, you cannot use them to name your variable. So def, short for definition, is another example of a keyword in Python. So you have definition or def, and then you put the name of your function. So this is the name that you will be using later to call the function to use it. So again, the same principles of choosing good name for your, like earlier we talked about choosing good names for your variables, so they're intuitive, you can understand and remember them later. So the same principles apply here, because you want to choose your, you want to use the function later, so the name should make sense. So yeah, so now we want to try to create a function that converts the temperature from Celsius to Fahrenheit. This is depending on what kind of program you're writing. This might be something that you need often. For example, in a standard systems, temperatures are usually in Celsius. And if you want to talk to someone, for example, from the US, Celsius may not make so much sense. So they're more used to Fahrenheit. So you need to run this function every now and then to convert the temperature. That's why we are defining this function. So here you put a bracket, and here you provide a parameter. So this parameter is the value that you will pass into your function, and based on that parameter, it does what it does for you. And in the second part of your definition, you need to have a return statement. Basically, return tells you what the function will return. So when you call the function, it will return this value that comes in front of the reserved key, the keyword return. You can also, if your function does not have an explicit return value, you can also skip this, but Python requires it. So even if you don't write it, it will be enforced somehow without, so it will be there. So this is the equation for converting temperature from Celsius to Fahrenheit. So this is what will be calculated when you call the function. Yeah, so temp is the variable, is the parameter you pass into your function, and based on that it does this calculation. So it multiplies your temperature by 9 divided by 2 and plus 2. So let's run this. Yeah, so as you can see, you don't get any output, and the reason is that you haven't used the function yet, you're just defining the function. So now that you ran this piece of code, you just made the function available so that you can use it later. So that's why you do not get any output. So, yeah, sorry. Yeah. So now we define the function. So the function should be accessible. If we need it later, we can just call it and we get the output. So let's try one thing. We want to get the freezing point. We know it's 0 degrees in Celsius. We want to see how much it is in Fahrenheit. So let's create a new variable called freezing point. Okay, so the freezing point is just a variable. You're calling the function Celsius to Fahrenheit, which you defined earlier, and you're passing in the number 0, so that will be saved into temp parameter up here, and then it does these calculations and it should return you the value. So now the function, you run the function, so the value should be stored in the freezing point variable. Let's get the output, see what it looks like. So let's print it out. Okay, so now we wrote the F string. So the freezing point of water in Fahrenheit is 32 degrees. So now we passed in the variable in our F string as we have done it before. There's another way of doing this, so you can just, instead of storing the output of the function into a variable first and then passing the variable into the string, you can just directly make the call to the function inside your F string. Let's see how that would work. Let's try for the boiling point of water. Boiling. Okay, so in this time we just made the call to the function straightly in the F string without storing it first into a variable. So we got the boiling point of water is 100 degrees Celsius, and in Fahrenheit it should be 212 degrees. Okay, now let's try this for another conversion. And now we want to convert the temperature from Kelvin to Celsius. And we know that for doing that, we just have to, well, degrees Celsius is 273.15 degrees less than degrees in Kelvin. So it's a very basic calculation. And here you will see that we can use the variable temp again. Let's see how that works. Let's define the function again. So this def defines Kelvin So one thing to note here, when you define your function, as you probably have noticed already, you put this colon sign and then it will automatically add indentation for the next line. So we saw this already when we were creating for loops, that indentation is important. And here again, it is telling Python that, okay, here the block of code for my function is starting. And once you're done with the definition of your function, you just go to the beginning of line, or you just go back to the previous indentation level to continue. So okay, so this is the definition of our function, and it will take a temperature as the parameter temp kelvins, and it will return it after reducing 270 degrees. So yeah, so as I said earlier, we chose a different parameter name here, temp kelvins, to just make it more clear, but you could have also used the same variable as before, temp, and it will not interfere with your previous function definition, because we will see this a bit later, but any function, any variable that you define within a function is only accessible within that function. So if you have multiple functions and each of them, if you use the same variable name, it doesn't interfere with each other, so it's perfectly okay. Okay, let's see how we can use our second function. Now we want to see what is the absolute zero in Celsius. Okay, so what we are doing now, we are calling the function again, the function that we just defined, and we are converting the temperature 0 degrees in Kelvin to Celsius. And we can see that we have done one thing a bit differently here, and that is that we have put the name of the parameter here and the value. So we could have the same thing as before would happen, so we could have just put 0 there without explicitly saying the name of the parameter. So you might be wondering, what's the benefit of this? Well, today we are seeing only examples of functions in which you have only one parameter, so you're passing in one parameter, but there can be situations very often that you have more than one parameter you pass into a function. So what Python automatically does, it just reads the values you provide in the same order that you have defined in the function. So if you have temp1, temp2, temp3, and you provide 3 values for them when you call the function, it will just automatically read them in the same order. But if you have a long list of variables, a long list of parameters in your function, you have to be careful with the order so you get them right. One way to make sure that the order, if you get it wrong, doesn't affect what value is loaded to what parameter is explicitly saying the name of the parameter. So in this case, it doesn't make any difference, but if you had more than one parameter, by saying the name, it will assign it correctly. You make sure that it's assigned correctly, even if the order is not right. So let's see the output of this using a f string again. So okay, so absolute zero in Celsius is minus 217, 73.15. Okay, so now that we are playing with different units of temperature, let's try another one. There is another unit for measuring temperature, which was developed by Isaac Newton, and it's not maybe as common as Celsius and Fahrenheit. So let's to find another function where we can convert temperature in Celsius to Newton. So take a few moments and try to define this function from what we have learned so far. We have the equation here. Okay, so how many of you got it right? You can just raise your hand. Okay, great. So let's run this and define our function. I'm just making sure that I don't have any typos here. So yeah, so the function is now defined and it should be, we can use it later. So now let's try another example. Now we want to convert temperature from Kelvins to Fahrenheit. So what we want to practice here is that you can make a call to another function within your function. So now we have previously defined a function in which we converted temperature from Kelvin to Celsius. Now we want to get Kelvin to Fahrenheit. Of course, we can. One more logical way would be to just redefine the equation, the equation we have developed, but now we want to practice something different, and that is, okay, we already have a function that can take care of converting temperature from Kelvin to Celsius, so what if we just convert it first from Kelvin to Celsius using what we already have available and then try to convert it from Celsius to Fahrenheit. So for this, we are making a call from within our function to the function that we had previously defined. So let's see how that would work. So we name our new function Kelvin. It will take an input name Kelvin as input. So this is the parameter. Okay, so what we did here, instead of like making the equation all over again, we used the functions that we had defined previously. So in the first call, we so as the parameter, we are getting temperature in kelvins, and we want to convert that to Fahrenheit. In the first step, we use the function we had earlier, kelvins to Celsius. So we convert the temperature from kelvins to Celsius, and then we use that other function we had defined, Celsius to Fahrenheit, to convert our temperature eventually to Fahrenheit, which is what we want. Okay, now let's try how this works. So we want to, let's use the function to calculate the temperature of absolute zero in degrees Fahrenheit. To get the output, just write a F string. Okay, so absolute zero in Fahrenheit is around minus 459 degrees. Okay, functions and variable names. I already mentioned this briefly, that when you define when you define a variable within a function, it's only accessible within that function. Let's see a few examples of that. Let's define a modified version of our Kelvin to Celsius function where the parameter values is still called temp Kelvin. So we have defined our function to accept temperature in kelvins as its only parameter and calculate temperature Celsius for us and return the value. Okay, so we can, you see that here we have defined the parameter, so it will be stored into a variable named temp kelvins, which is only accessible within the function. So after defining the function, if you try to get the value of temp kelvins, which was defined up here, you will see that you will get an error. It's telling you that the variable with a variable with this name is not defined. Let's try it with the other variable that we have defined here. So this is not the parameter we passed in, but just a variable that we defined within the function to see if we get any different results. The same thing happens here. So because you defined a variable within the block of code that you had in your function, it's only accessible from within. So if you call it from outside, you will get a name error. So you might be thinking that, okay, I'm getting this error because we haven't called the function yet. Maybe if we call the function first, it would make a difference, but let's try that. So let's call the function and convert 293 degrees to Celsius. So Kelvin to Celsius. So now we run the function, we got the output. Let's see if we can now access that variable. And no, still you get the error. So like what I said, if you define a variable within a function, even if you run the function after the function is run, you cannot access that variable anymore. Yeah, so this has many benefits. So if you have a larger program where you have a lot of functions and there might be like this way you don't make mistakes. You just know that even if you use the same variable name in different functions, it will not cause any problem. Yeah, is there a question? Yeah, probably you have done something differently when you were defining your function. Look at the equation and make sure you have typed in the exact same thing. Have I typed in something? Okay, yeah. Yeah, so I had a typo. You had the correct value. Yeah, so it should be 20. Thank you. Okay, let's try to define a new function now. Let's call it Kelvins to Celsius 2. Okay, so now we are trying something different. We defined a new function again that converts temperature in Kelvin to temperature in Celsius. So let's define a global variable. Global means that it's not defined within this function. So you should be able to access it from within the function as well. So let's just call it temperature. Now let's try to run our function. So the output we get is 30 degrees. Let's see if it has changed the variable value temperature that we had earlier. So you can see that the value for our temperature is still 303.15 degrees. And the reason is that this was a globally defined variable. So you define this variable up here before you call the function. So it wasn't defined inside the function first. So once you do calculation within the function, it updates the value of that variable only within that option. But after it's done, if you call that variable again, the value you get is the original value you had. So if a value of a variable that is globally defined changes within a function, it won't be updated later when you access it from outside the function. But this is something to remember and be careful with. So don't assume that the value is now updated because you used it in your function. So let's look at another example. So now we define the new function where we get in the parameter temperature, then we have the equation. So we have temperature minus 273.15. Let's get the output. Let's try it with Second 30 degrees. So another example of how this variable work within a function. So even if you update it from within the function, the value you have is what you had earlier. So it was this 303 degrees. So that's why we get this output and not 0. So that was function in Python. Do you have any question from this part? Okay, if now, okay, let's take a break. How long? 15 minutes. Okay, let's take a 10-minute break and we will come back and continue with the rest of the lesson.